Hi guys, I'd like to complete this worksheet with you, investigating polynomials. Okay? Excuse me. When we are talking about investigating polynomials, there's some vocabulary I need you to know. Okay? First of all, polynomial. Right? What I need you to know about a polynomial is that it is a monomial or the sum of monomials. Okay? This term, like we talked about yesterday, it has one term, and so it is called a monomial. This term, here's a term, here's a term. There are two terms, so it is a binomial. Okay? Anytime it's separated by an addition sign or subtraction sign, that shows you that that's a new term. Okay? There can be parentheses and things like that, but we'll get into that later. Okay? 1, 2, 3 terms is a trinomial. And 1, 2, 3, 4. So 4 or more terms is a polynomial. Okay? The degree of a polynomial. Yesterday we talked about the degree of a monomial, and you know that when we're looking for the degrees of the monomials, that you're looking at the exponents, right? The exponents in the problem. And so, for example, this problem right here, this sample that you're given, 5 halves x squared y to the third, the degree of this term, this one term, would be 5 because that's the sum of the exponents. Okay? But if we're talking about the degree of a polynomial, the degree of the polynomial is equal to the highest degree of the monomials. Excuse me. Okay? So if this is your monomial, its degree is 5. So the degree of the polynomial in this case is 5. You see that? Monomial terms. Sorry about that. Okay? So in the next problem, excuse me. Okay? So in the next problem, what's the degree of this first term right here? Well, the degree of the first term is 2. And what's the degree of the second term? 1, because remember there's a 1 as an exponent there. So which of these is higher? Hopefully you realize the 2 is higher, so that is the degree of the polynomial. Okay? Here it's 2. Here is 1. And here, since there are no variables, the degree is 0. Okay? So the degree of the actual polynomial then is 2, because that's the highest monomial degree. Okay. Last but not least, degree of this term is, well, an exponent of 4 on this variable, and an exponent of 1 on this variable makes that a 5. An exponent of 1 here and 2, that makes that 3. An exponent of 1 here and 1 here makes that 2. And since there are no variables there, that one is 1. So the highest out of each of those terms is a 5, so the degree of the polynomial is 5. Okay? So when we're doing operations with polynomials, hopefully you realize we're combining like terms. Okay? If there's any multipliers out front, we have to take care of that first. There's not any multipliers out in front of this. Okay? So it just becomes what it is. Negative 4x squared minus 3xy plus 5y squared. Now here, this set of monomials or a polynomial has a multiplier. So we've got to multiply that 2 to each term inside of the polynomial. Okay? So when we're multiplying there, we are going to multiply the 2 times the 3x squared, and we'll get 6x squared. And multiply the 2 times the negative 3xy and get negative 6xy. Multiply the 2 times the negative 5y squared and get minus 10y squared. Now all that's left to do for us is to combine our like terms. Okay, so negative 4x squared and 6x squared. Negative 4x and 6 is 2, so that leaves us with 2x squared. Remember, we do not mess with the exponents when we're adding or subtracting. Okay, that shows us what a like term is, and we do not mess with those exponents. Okay, so we have 2x squared. Then we have a minus 3xy and a minus 6xy. Well, minus 3 and minus 6 is a negative 9xy, so minus 9xy. And then I have a 5y squared and a negative 10y squared, which gives me a negative 5y squared. Okay? The second sample problem here is a difference. Okay, this was a sum, this is a difference. With the differences, we have to be careful, right? Because we're subtracting every single term in this parenthesis right here. Okay, in this group. So what we're actually doing is we're distributing that, because really, if you want to be technical, there is a 1 in front of that parenthesis, so we're distributing a negative 1 to each term. So this parenthesis does not have a multiplier, so it's just 3x squared plus 6xy minus 7y squared. And I want to show you another strategy that you might employ here in a problem like this. Okay? A negative 1 times a negative x squared is a positive x squared. And instead of writing it out to the side this direction, you might find the term that's already like and write it underneath it. Okay? Negative times 5xy would be a negative 5xy. I found the term it was like and wrote it underneath it. Negative 1 times a negative 2y squared would be a positive 2y squared. Now all I have to do is combine my like terms, and I've lined them up, so I'm just combining them very close to each other. Okay, so I get 4x squared. I get plus 1xy, and remember, if you don't want to write that 1, you don't have to. Okay, it's an understood one, and then minus 5y squared, a negative 7 and a positive 2. Okay. On the next page, there are a couple more sample problems I want to show you. Okay, the most important one that I want to show you, however, is number 5, but we'll get there. Okay, so on number 3, distribute here and here, and we get 15. Now we're multiplying, so we do have to talk about the exponents on each of the variables. If you'll remember from yesterday, the rules that we talked about is that when we're multiplying like bases, we add our exponents. So this is going to end up being x to the third. This is going to end up being y to the third. Okay? Excuse me. So then we multiply to the second term. Okay? Multiply the numbers like it asks us to, but when we combine the exponents, we add the numbers, the exponents. Okay, y to the fifth. All right. Now in the directions, it does ask us to classify each answer by its degree and number of terms. So hopefully you realize this is a binomial because it does have 1, 2 terms, and its degree. Well, let's see. This is 6. And this is 7. So it's going to be the degree is 7. Okay. Number 4. We talked a lot about a little bit about this on Friday. How you guys want to do FOIL, okay? Because that's how you learned it. But remember, what I said is that that's what we say when we're little. That's what we learn. That's the actions that we're doing. But what I need you to understand that this is really the distributive property. Okay, that's really the property that's happening here. So we are going to do the first 2 terms, but really I'm just multiplying this term times each of those and this term times each of those, okay, which is the distributive property. So x times x is x squared. X times negative 3 is negative 3x. 8 times x, which is 8x, and 8 times negative 3, which is negative 24. When I combine my like terms, I get x squared plus 5x minus 24. Okay, I'm going to do number 6 real quick before we talk about number 5. Okay, again, same kind of deal. 4x squared minus 6x plus 6x minus 9. Now notice what happens with these two like terms right here. If I have a negative 6x and a positive 6x, that goes to 0. Okay, so all we're left with is 4x squared minus 9. Okay? Number 5 is a really big deal. Okay? Number 5 is a really big deal because if you're thinking you can just square each of the numbers inside, then you don't understand exponents, and that's what I'm worried about. Okay? Something squared means it's that number times itself. Not each of the individual parts, but that number times itself. Well, if I have x plus 4 squared, then it's really x plus 4 times x plus 4. Which means we're going to do it like 4 and 6. We're going to distribute the x and get x squared. Distribute the x here and get 4x. Distribute the 4 here and get 4x. And distribute the 4 to the other 4 and get 16. When I combine my like terms, I get x squared plus 8x plus 16. If all you ever do is square the first term and square the last term, you'll always get it wrong because you'll miss out on this middle term every time that you get from the distributive property. So please, 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 please be very, very careful of that. Okay? The last 2 word problems I'll show you really quick. I probably won't take you through all the work. Just make sure you understand what to do. A rectangle has a width represented by 4x plus 5 and a length represented by 3x plus 2. Sorry about that. So if we have a rectangle and the width is 4x plus 5 and the length is 3x plus 2, how can you find the area of the rectangle? Okay? Hopefully you remember area is length times width for a rectangle. So I would do 4x plus 5 times 3x plus 2. Okay? And that's how you set that one up. Remember on 4, 5, and 6 to go back and do the degrees and what kind of term, the number of terms it has, classify it by its number of terms, so don't forget to do that up here. Here, we just do the distributive property. I can let you do that. You can do that fine. The diagram below shows an isosceles triangle. Find the expression that represents the perimeter of the triangle. Okay? If you'll remember your qualities of an isosceles triangle, if this leg right here is 3a plus 5, then this leg right here is 3a plus 5. And if we're finding the perimeter, we're finding the distance around. So we have 3a plus 5 for this leg. We have 3a plus 5 for this leg. And we also have 3a squared plus 2a minus 1 for the base. Now all that's left to do is for us to combine our like terms. 3a squared, there are no other a squared, so I just end up with 3a squared. I have a 3a, and a 2a. So 3 and 3 is 6, and 2 more is 8. So I should have 8a. And then I have a 5 and a 1. And another 5 right here. So 5 and 5 and a negative 1, in fact. So that should give me 9. So that is my perimeter of this isosceles triangle. Okay? You have these 10 problems on the practice problems on the back, and I hope you have a great weekend.